In this video, I'll talk about how to derive the relationship between displacement, velocity, and acceleration. Or in other words, we're going to find out this formula here. We're going to derive this formula here, okay, just from the basic definition. So let's start with how do we define acceleration. First, we're going to define acceleration. And there are two terms of the acceleration. The one is the average acceleration and the other is instantaneous acceleration. Okay, so the average acceleration is defined as the change in the velocity. This is the change in the velocity over a certain period of time. So this is the final velocity and this is the initial velocity. So the difference is the change in the velocity, and if we divide it by time, then this gives us the average acceleration. So from this equation, we're going to solve for Vf, that is the final velocity. And the final velocity will be simply equal to Vi plus A bar. What does the A bar mean here? If you have something and if you put a line on top, then that gives you the average. So this is the average acceleration. And here, our motion, the motion I'm talking about, is the motion in which the acceleration is constant. Acceleration is not changing with respect to the time. It is a constant acceleration. The example of a constant acceleration is when you drop an object under the influence of gravity. So for example, if you have a ball and if you drop it, then it falls with a uniform acceleration. That's the motion I'm talking about. But if the acceleration is itself changing with the time, then the motion could be complicated. And here I'm not going to talk about that one. So keep in mind, this is for the motion where the acceleration is constant. Acceleration is uniform. It is not changing with respect to time. So now look at this equation here. Vf is equal to Vi plus A bar t, and this is the average acceleration. If we assume A is constant, this average acceleration is constant, it is not changing with respect to time, then if we plot a graph, this is the time and this is the velocity, okay, and this velocity could be at any time. Here I can say Vfx at any position, at any time or any position. Then it has to be a linear relationship. That's what it does tell you. It is a linear relation, okay, and this is the initial velocity and that's your final velocity. And if we analyze, so this length here gives you the initial velocity and this length here gives you the A bar t. Now here is the interesting part here and the point to be noted. Here you see that as this A, which is the average velocity, or we have assumed it is a uniform velocity or the slope is constant. For any graph, if the slope is constant, then the average velocity can be expressed as an initial and the final mean, or in other words, the average velocity can also be expressed as the arithmetic mean of the initial velocity plus the final velocity. Okay, so if I know the velocity at this point and I know the velocity at this point, then my average velocity will be given by this equation here, the initial velocity plus final velocity divided by 2. Okay, so now we have two equations so far, and now again let's go by the definition one more time. How do we define the average velocity? How do we define? If you have a car, now let's say a car is moving, okay, a car is moving, okay, and it goes from point A to point B. This is its initial position and this is the final position. So how do we define the average velocity? The average velocity is defined as the final velocity minus the initial velocity, that we call the displacement divided by the time. So again, the average velocity is defined as the final position minus initial position divided by the time. This is what we also call the displacement divided by the time. Okay, so far we did not do anything complicated at all. We just wrote down all the basic definition. Okay, all the basic definition, the way we define the displacement, the way we define the average velocity. Okay, so now let's take at the equation 2 and equation 3. Both represent the same thing, that is the average velocity. So if we equate them together, this has to be equal because it in fact giving you the same information from two different perspectives. So this and this has to be equal. That's what I've written here. Now I'm going to solve for the final position. Then the final position will be equal to this one. This is just a simple math. So this is how it has to look like. xf is the initial position, xf is the final position, xi is the initial position, and if I multiply this side by t, then we have half vi plus vf times t here. So we got this equation now, and we already have got the final velocity in terms of average velocity here. So I'm going to plug in this final velocity into this equation here. All right. Okay, so let's do that. So xf xi plus half vi as it is, and v final velocity is given from this equation, which is vi plus a bar t. That's what it is, and this time this is t here. So if I add this two together, this will be 2 vi, and it will be cancelled out by 2, so we have simply vit, and then if I multiply this side, half a bar and t squared. So this is the equation we have. This is the formula we have. And remember, this is the average velocity here. And again, if this is the average acceleration. If the average acceleration or the acceleration is constant, it is not changing with respect to the time, then average acceleration is exactly equal to the instantaneous acceleration. You might be wondering how come. Do not worry about this one. I'll explain here. What is the uniform acceleration means? That means it is not changing with respect to the time. Or here, now let's take a look here. This is the acceleration of constant acceleration. It is not changing with respect to the time. Time is changing, but the acceleration is constant. So if I measure the instantaneous acceleration at any point, it has to be exactly equal. Or even if I take the average, the instantaneous acceleration would be exactly equal to the average acceleration. All right, so here you can simply replace instantaneous average acceleration by the instantaneous acceleration. And if you want to analyze the graph, then if this is the time and this is the velocity, then the velocity changes linearly with respect to the time. The acceleration is constant. It is not changing with respect to the time. And now if you look at the position time graph, then it will be quadratic in nature. This is quadratic in nature. Okay. When I say quadratic, that means it varies as a proportion of t squared. And you can see here, this is the plot here. This plot here. Okay, so this is the initial position. That's the position at any time. So as you see, this varies as t squared. It has to be quadratic in nature. So this is how we derive this formula here. Okay, remember, this is the position, and this is the final position, and this is the initial position. And sometimes you also have seen this way too. X is equal to ut plus half at squared. This one and this formula is exactly the same. Here, S is the displacement, which is equal to xf minus xi. So this is it from this video. If you have any questions, any concerns, write to me or write down your questions in the comment section below. And do not forget to like, share, and subscribe the channel. Thank you very much.